Okay, how about the load instruction? Remember what the load instruction does? Well, it uses the ALU. It basically looks like an ADC instruction at some level because it's taking the contents of the RA field and adding the sign extended constant. So if you actually look in the diagram here at the load column, you'll see that it looks a lot like an ADC instruction in the sense that B cell is 1. Okay, and so now what's coming out of the ALU is the contents of RA plus the sign extended constant, but we don't use that answer directly. That is now the address, and you can see we send it over here to the memory, into the address port of the data memory. And so the instruction memory and the data memory are actually the same memory. It's just two separate ports, right? I can ask the memory both for an instruction word using one of its read ports, and on the other port, other read port, I can ask it for a different address. So I can actually, just like the register file had two read ports, main memory has two read ports, one of which is used to fetch instructions, and the other which will read from the same memory array, but usually different addresses, will read a data word out. We'll take this data word, and the data that comes out of memory is then routed through this new multiplexer called the WD cell mux, okay, routed back to the register file, and that becomes the result of the instruction. So if you look here in your control table, you'll just see that we've added a new WD cell control line. The WD cell mux selects from one of three values. From, well, we haven't shown you where value 0 comes from, but when WD cell is 1, we're going to select the ALU output, and when WD cell is 2, we're going to select the data output of memory. And then we're going to route, whichever one of these gets selected by the WD cell signal gets routed back into the register file. And so WD cell would be 2. In other words, we want selecting the 32-bit value coming back from memory, okay, in the case of a load instruction. That's what gets written back into RC. Okay. So what we've really done is to go off and add a data memory so we can read and write into it for loads and store instructions. And we've added this WD cell mux, which allows us to choose either the ALU value or the output of the memory system, of the data memory, to write back into main memory. Yes?
What does 0 do?
I'm sorry, what does? Oh, we haven't. I'll show you in a slide or two what we're going to use it for. It turns out there's one other piece of information that can be written back into the register file. And when we get to jumps and branches, we'll see what that is. Okay, so.